Everyone, I am Vinita, Assistant Professor, Department of Computer Science from St. Josephs College of Arts and Science for Women in Ozu. Today, I am going to represent the topic logic-based and state testing, which are advanced techniques used in software testing. These techniques help testers verify the logical correctness of a program and understand how the system behaves under different conditions. Topic: Introduction to Logic Basic Testing. Logic-based testing focuses on verifying logical conditions and decision-making structures within a program. It examines how the program handles different input and evaluates conditions. This method verifies Boolean expressions, conditional statements like if-else, and complex decision rules. The main objective of logic-based testing is to ensure that the program behaves correctly under all possible logical conditions. Next topic: logical conditions in programs. Software programs use logical operators to be control the flow of execution. The most common operators are and, or, and not. The and operators requires both conditions to be true. The or operators requires at least one condition to be true. The not operator reverses the truth value of a conditions. In complex programs, multiple conditions may be combined together, which makes testing very important. Next, example code. Let us look at a simple example program. If the age of a person is greater than or equal to 18 and less than or equal to 60, the program prints eligible for program. Otherwise, it prints not eligible. When testing is programmed, testers must check different conditions such as age below 18 and the age below between 18 and 60 and age greater than 60. This ensures that the logical conditions work correctly in every situation. Table testing. Decision table testing is a technique used to represent complex logical conditions in a structured table format. This lists all possible combinations of conditions and the corresponding actions. For example, conditions like age and ID availability determine whether entry is allowed or defined. This technique ensures that every possible logical combination is tested. And the next topic, cause effect graphing. Cause effect graphing converts system requirements into a graphical representation. In this method, causes represent input conditions and effects represent system outputs. The relationship between causes and effects is shown using logical connections. This helps testers generate test cases by analyzing different combinations of inputs and outputs. And the next topic, introduction to state testing. State testing focuses on the dynamic behavior of software systems. It analyzes how a system represents to different events and transition between states. This technique is useful when system behavior depends on previous actions or current system conditions. Example include login systems, communications protocols, and embedded systems. And the next topic, key state concepts. State testing includes several important concepts. A state represents the current conditions of the system. An event is an input that triggers a change in the system. A transition is the movement from one state to another. An action is the output produced when a transition occurs. Next topic, state diagram example. A state diagram visually shows different states of a system and how the systems move between them. For example, in a login system, the system starts in the ideal state. When the user enters credentials, the system checks the password. If the password is correct, the system moves the login in state. If multiple incorrect attempts occur, the account becomes locked. Next topic, state transition table. A state transition table shows how a system moves from one state to another. It includes the current state, the input event, the next state, and the resulting action. For example, when a user enters the correct password, the system moves from enter credentials to logged in. If the password is wrong 3 times, the systems move to the locked state. Next topic, transition testing. Transition testing ensures that the system handles state changes correctly. It verifies valid transition between states. It also checks invalid transition to ensure the system prevents them. In addition, testers examine how the system handles unexpected inputs. For example, attempting to transfer money without logging in should trigger an error message.